We are now going to look at the law of cosines. The law of cosines is really used when the law of sines doesn't work. So first off, the law of cosines, all three of these mean the exact same thing. I like the bottom one the best, just because when I see c squared equals a squared plus b squared, that looks like the Pythagorean theorem, and then minus 2ab cosine of c. So really, how does this kind of work? Well, if you remember the law of sines, we were looking for an angle-side relationship. The law of cosines, if I would try, whenever I need to use the law of cosines, if I come up with a scenario that contains two variables within the law of sines, then I know that I need to use the law of cosines. So sometimes you're going to be given an angle, sometimes you're going to be asked to find an angle using the law of cosines. In either case, when I look at this formula, I see c squared, this is my side length, cosine of c, that's my angle measure. And if you notice the relationship, they are across from each other. So if I'm given an angle measure down here at c, then I want the side length c, the one that's across from it, by itself. And then a and b doesn't matter. Okay? So let's look at an example. I want to find x, round to the nearest tenth. It says to use the law of cosines, but I'm going to show you how do I know when to use the law of cosines instead of the law of sines. Well, let's say that I try and use the law of sines. I would first look for my angle side relationship. So I see the 28 and x. So I would go sine of 28 over x equal to, I see a side length of 11, but no angle measure across, and I see a side length of 9, again, no angle measure across. So then I'm left with two variables. Say I use angle A, sine of A over 9. Notice how I have a variable here and a variable here. That doesn't work too well for us. So if I end up with two variables, then I'm going to use the law of cosines, which we said is this. Again, we are going to look for our angle measure, C, because the side length across from it also goes by itself. So my angle measure is 28, the side length across is x. So x is going to go by itself. X squared equals a and b, it doesn't matter, those are your two other side lengths. 9 squared plus 11 squared minus 2 times 9 times 11 cosine of 28. To solve for x, it's very close. I need to get x by itself, so I need to get rid of the squared. We're just going to square root both sides, and that's what you're going to end up typing into your calculator. I'm going to take out my calculator now. We're going to type in everything as I see it. So we're going to say we want the square root of 9 squared plus 11 squared minus 2 times 9 times 11 cosine of 28, which gets us a length of approximately 5.2. Is your side length. We can do one more really quick. If we look at, say, maybe 3a here, again, using the law of cosines, we know that the law of sines isn't going to work. Find your angle measure. The side length across goes by itself. That'd be x squared. Your other two side lengths, 15 squared plus 19 squared minus 2 times 15 times 19 cosine of 125. To solve again, we are going to take the square root on both sides, and When we take the square root on both sides, plug it into our calculator, it's going to come out to approximately 30.2 in your calculator.